and its levels must be maintained to maintain good public relations. Exposure evaluation. The next important task is when you know the source of exposure, source of any contamination, then you must measure that exposure, that how it may damage you, and you must have means through which these exposures should be limited so that person, property, and environment should not be damaged. So if health hazards are to be controlled, they must be recognized and evaluated. Estimation of the toxicity or intrinsic hazard is needed for each material identified in an inventory, that you might have any catalyst, that you might have any solvent, that you might have any spotter, that you might have any lubricant, because lubricant may get fired, may get exploded, and may become a risk or a health hazard. So each and every inventory must be evaluated in terms of its exposure, in terms of its toxicity, in terms of its hazard ability. And such information for many chemicals are presented in the form of material safety data sheets, MSDS. Therefore, a risk assessment must be performed for each material during the life cycle of its use, that this material must be stored in such a way it will be heated to that temperature, pressurized, and then leave from our system and so on. However, it is generally not necessary to make this estimate of a chemical exposure for each and every chemical, because generally we have understanding of some of the common materials that we generally use, such as coal, such as water, and so on, and their assessments may not be needed at each and every usage. And what are the different methods through which we can estimate the exposure through an air? For metal, we use atomic absorption spectrometry. For VOCs, volatile organic compounds, we use gas chromatography. For noiseless dust, coal dust, gravimetric analysis, that means measurement must be done. Particle count is done for asbestos release. Ionic special electrodes are used for halogens, ammonia, and HCN, and X-ray diffraction for silica, and colorimetry for any miscellaneous items, through which we can measure their TLV, LD50 value, and so on, which must be indicated for the use of those materials. Exposure hazard control. After knowing the sources of exposure, after knowing the evaluation through MSDS, through their life cycle analysis, through their hazard operability analysis, HAZOP, and so on, we must know how these must be controlled so that these hazards and these exposures will not become a risk during their life cycle usage. When exposure problem exists, decisions need to be made regarding the implementation of hazard control measures for the purpose of reducing those exposures. Decisions must be made relative to the degree of risk reductions that need to be maintained so that your hazard will not become a risk, and it should not damage the three levels. One is person, second is property. Property doesn't mean the land. Property means the equipment that you are using, because it is one of the major costs that we have put. Of course, the land is also important. It should not also be damaged. And lastly, environment should not be damaged. Any questions?
स्लाइड्स ही बना रहे हैं अभी तो।
Any questions? So series of choices must be made for a wide range of options available to achieve that desired risk reduction. So that whenever we have an exposure of the release which may damage person, property and the environment, we must know how much damage it can cause. We must know the measures which can control it to below its TLB value and below its LD50 value, which we have previously understood. So there are three general options or control principles which are being utilized to reduce the exposures of workers to occupational health hazards. And these are source controls, transmission barriers, and personal protection. So these three control measures we generally take. You must remember these control measures because these will be applied in our HAZOP study or faulty analysis. Whether we are controlling the source, whether we are providing any barriers, or whether we are providing protection to the persons, so or sometimes we need all three these levels of controls to limit this exposure to any hazard or contamination. The source control in which we must reduce the risk of spillage, we must reduce the emission or venting, we must maintain our system tight and controlled in such a manner so that your material may not get out of the things and you can control the source from the first hand. So basic and detailed changes in the way should be done in such a way that you might be introducing any uh, valve, you might be introducing any new equipment, you might be introducing absorption system which limits your exposure or emission, so which can eliminate or reduce the exposure. And the primary purpose of local exhaust ventilation is generally to control the contaminant exposure by establishing a control surface of barriers. And sometimes we introduce barriers in, if you remember, we introduced the mister's pad to reduce the mist that is going into the environment. We generally introduced a top plate in our electrostatic precipitator bag houses, filters, so that if any dust is going with the top exhaust gas, it must be sent back by gravity. So they are transmission barriers. Local exhaust ventilation is sometimes cumbersome, inconvenient, and required considerable maintenance. However, it will reduce the exposure. And these ventilation options are generally used the principle of dilution, that would dilute the limit to less than LD50 and TLV value so that we have a safe environment. These contaminants must be diluted or removed from the air from your workplace. So the objective of dilution is always to prevent any exposure, but to keep to exposure to acceptable low values by diluting it by applying any ventilation option and so on. So various control options or combination options need to be selected, and sometimes we have to do the cost analysis of those control options which are to be optimum to be applied, and sometimes we have to overcome the cost so that the safe environment for three levels: person, property and environment must be maintained. So one of the most important and most dangerous event is fire and explosion hazard that may occur in any chemical or petrochemical industry. And a major loss of life and property generally occur in our chemical and petroleum industry is due to the fire and explosion. For fire, we always know that three things are necessary. The fuel must be there, oxidizer must be there, and ignition source must be there. And this is unnecessary fire. This doesn't mean the combustion fire that we are maintaining in a furnace. This is the fire that might establish on your exhaust, that might establish on your storage and inventory pile, or your tank in which your fuel is being stored, and which become a hazard, and if occurs repeatedly, it may become a risk to property and so on. So three things are necessary for fire to establish: a fuel, an oxidizer, an ignition source. And if we cut any of the three sources, a fire will be extinguished, and we will have a safe environment. And we must again know that some of the terms which apply to fire and explosion. The first is lower flammable limit. Low flammable limit actually indicate the minimum concentration of fuel air required for ignition at ambient temperature. So this is the lower concentration of the fuel which is required with the air, and the proportion must be known that 2% of the methane must be necessary with rest 98% air to start combustion. If your methane is less than 2% in the air, in any container, in any system, and in any boundary, in any controlled volume, then its LF value has not been reached, and the combustion will not initiate, or fire will not be established. And these terms you will also study in energy engineering or energy engineering lab. A mixture of the fuel and air below the LFL is too lean to burn. Concentrations above which ignition will not occur is labeled as upper flammable limit. That means if your methane concentration is 95% and rest 5% is air, it will not combustion. I'm just giving an example. So that means this is called as the upper flammable limit, UFL. Your fuel will only burn between LFL and UFL. If your fuel concentration with respect to air is below LFL or above UFL, it will not combust, how much ignition source you provide. So these limits should be known, and proper ventilation or proper airing of your storage device or the storage system, whether tank, whether pile, and so on, must be done in such a way so that these limits are not reached and combustion may not, or the fire may not be established. So concentration of oxidizer that must be present for the ignition is called as limiting oxygen index. This value must also be known, and the flash point and auto ignition temperatures must also be known for the fuel. And these all parameters are generally indicated whenever we are dealing with any fuel, whether liquid, gas, or solid. What is auto ignition temperature? Temperature at which ignition will occur without the presence of spark, because temperature or pressure wave has already been created within the fuel so that the fuel might get auto ignition. And the liquid temperature at which the concentration of fuel in the air becomes large enough to ignite. That means if we provide a source of ignition, it will catch a flash of the fire, and that is called as flash point. There are two units in our energy engineering lab to measure the flash point of the liquid fuels. One is Penske Martin and one is Cleveland open cap tester. And these flash points are generally indicated both in closed systems and open systems, because we are dealing with fuel in both of these scenarios. That we may be dealing with fuel in open fire or open storages, and we may be dealing with the fuel in closed storages where they may form a vapor pressure that may be dangerous may lead to fire or explosion. Any questions until now? So the next term is explosion, and what the explosion is sudden and generally catastrophic release of energy causing a pressure wave. A sudden and catastrophic release of energy causing a pressure wave is termed as explosion. An explosion may happen without a fire. That means the failure of our steam boiler tubes because of high pressure may lead to a steam explosion at which high temperature, high pressure steam will leave or break the tubes because of erosion or corrosion of the tubes, or because of the non-containment of the tubes, due to which it will lead into an unhealthy event, unsafe event. And we generally have two more terms, detonation and deflagration, connected with explosion. In detonation, the chemical reaction propagates at supersonic velocity, and the principal heating mechanism is shock compression. That you might be compressing a fuel and it may react or may catch a fire or may create an energy release at a supersonic velocity will be called as detonation. And deflagration, in which we have a subsonic velocity. The combustion process is the same as in normal burning of flammable mixture, with the reaction propagating at subsonic velocity, and we experience a low pressure buildup. So explosion in general is a sudden and catastrophic release of energy which may create a pressure wave. Detonation, in which this release of energy is at supersonic velocity, and deflagration, in which this release of energy is at subsonic velocity. So explosion can occur from a purely physical reaction or chemical reaction or a nuclear reaction. A physical reaction is the explosion of a steam tube. A chemical reaction is the combustion, and nuclear reaction in which nuclear fuels may reach towards detonation level and may explode with a high pressure wave. And we generally have two terms. One is BLEVE and the second is UVCE. The first is BLEVE, the boiling liquid expanding vapor explosion. Heat leak into a container filled with the boiling liquid results in excessive vaporizations accompanied by a steady pressure buildup that ruptures the tank. That means you might be having a liquid in a vessel which is closed, and its vapors are being released because of high temperature, because of vaporization and so on, and these vapors may reach to such a level of pressure that it may rupture the tank, and that explosion is called as BLEVE, boiling liquid expanding vapor explosion. Second is UVCE, unconfined vapor cloud explosion. That your vapor that is being generated from any liquid is being released, and it may not be dispersed, it may not be getting diluted. So it may be forming a large cloud of gas or vapor, which may become flammable when any ignition source is there or auto ignition is reached. So both BLEVE and UVCE must be avoided. So these are all the hazards that we are studying: fire, explosion, its different types, and so on. So ignition sensitivity, that is one of the important parameters, must be understood, and it always depends on ignition temperature, minimum ignition energy, and minimum explosion concentrations, which are of course between LFL and UFL, limit of any fuel that we are considering for our system. So maximum pressure measured during a test explosion must be known, and your equipment must sustain those pressures. Maximum rate of pressure rise which our walls and fittings can bear. So these things must be tested, must be recognized. So that's why boilers are always inspected again and again, and always their tests are being performed. So possible sources of fire are reduced by eliminating unnecessary ignition source. So again, source limitation, transmission barriers, and personal protecting. So these are the three means through which we can limit the exposure. So the second is transmission barriers are personal protections. This include fire alarms, temperature alarms, firefighting equipment, sprinkler systems, which may be automatic, which may require which may require any personal attention to create a safer environment from any unhealthy or unsafe event. We generally have four classes of fires. The first class of fire in which solid burns, which is called as class A fire. Class B fire in which liquid or gas burns. Class C fire, which is in which class solid, liquid or gas burns, but in the presence of electrical circuit. So, and class D fires consumes actually metals. So we must know the type of the fire that is being established, based on which we can apply an extinguisher and we can apply any limiting factor to our system. So any question? So fire protection systems may be passive, may be active. Passive fire protection systems which do not require any action at the time of the fire. They are designed and installed at the time of the plant is being built and remain passively in place until needed. So the best example is sprinklers. That we have installed sprinklers. If your temperature of the coal pile increases above your or near to your auto ignition or flashpoint temperature, your sprinklers will get alarmed by themselves because of control, which will set a signal that temperature has been reached to a threshold value, and now sprinklers will start sprinkling water or any extinguishing material. So these are passive fire protection systems which do not require any persons to activate them. Active systems include such agents as water sprays, foam, and dry chemicals that require any action to be taken, either by plant personnel or as a response system, which may be automatic fire protection systems and so on. So they are active fire protection systems. And we must know what category of our hazard and its ability to become a risk is there, especially with respect to inventory, either with respect to our raw materials, fuels, or our products. And we must categorize, and any of these or combination of both must be installed on our system. So our equipments are generally designed in such a way so that they should meet the required standards as recognized by any organization. So some of the organizations that generally put standards for our equipments which may have the ability to store any of these materials like fuels and so on, and these units must be designed or coded with respect to these organizations. American Standard Association, American Petroleum Institute, ASME, ASTM, American Society of Testing Materials, Factory Mutual Laboratories, National Fire Protection Association, Underwriters Laboratories, which actually put some of the codes and standards to which materials must be handled, units must be designed, and procedures must be followed for any treatment of fuels and so on, because generally for fuels we have ASTM standards or any testing of the materials or chemicals which defines that how these materials should be dealt in a laboratory or on industrial scale. So questions? So every attempt should be made to incorporate all the facilities for health and safety, protection of plant personnel in original design. So while designing, we must know what protections and health and safety protections we can adopt, uh, which may be walkways, which may be stairs, which may be working area provision, which may be providing any signboards that must be defined during design, that they must be provided with these units to have a safe and healthy environment for our plant personals. This include but not limited to protected walkways, platforms, stairs, work areas. Physical hazards, if unavoided, must be clearly defined. In such areas, means of egress must be unmistakable. All machinery must be guarded with protected devices. Medical surfaces and first aid services must be provided to the workers. And you might study all these things in your maintenance engineering in your 7th or 8th semester. So Occupational Safety and Health Act must be followed, and there are generally two standards which we generally follow. One is with respect to toxic hazardous substances, and second is occupational noise exposures that must always be followed. Because if you are dealing with any chemicals, you must know the toxicity and hazardability of those substances. And you must know, if you're dealing with machinery, you must know the noise exposure that may happen to our systems. And these toxic materials may be carcinogenic and may come to the environment by vapors, fumes, dust, and other media. An important term which we generally use is loss prevention. Loss prevention is a financial term which is being applied in chemical industry on an insurance term, where the loss represents the financial loss actually, which must be prevented before any risk or accident had happened. कि आपके प्लांट के ऊपर कोई एक्सीडेंट या कोई आपके पास रिस्क होने से पहले आपने उसको प्रिवेंट किया हो by any insurance, that is called as loss prevention. Loss not only represents the cost of repairing and replacing the damaged facility, taking care of the damage claims is also a loss prevention. That if any event has happened, how you have dealt into your claims in such a way so that this event may not happen again in the future. And loss not only represent that the person, property, and the environment is being lost. Loss doesn't represent that you might be repairing the equipment. It also represents the earning because of loss of production during the repair period, any associated with lost salaries, opportunities, and so on. So this is all about the financial loss that might occur because of any exposure, because of any health hazard, because of any contaminant release which is toxic, which may lead to a risk and later on fire, explosion, or an accident. And we must limit our hazards to those conditions which we have earlier studied. For flammable materials, UFL, LFL must be known, auto-ignition, flame, flash point, limits of oxidant must be known. For other chemicals, LD50, TVL values must be known and indicated, and they must be applied in appropriate manner. So identification assessment of the major hazards must be done. Control of hazards by appropriate means. That means source containment, transmission barriers, and personal safety. So containment, substitution, and improved maintenance may control the hazard. Control of the process, that your process must be controlled. If you must be able to measure the temperature automatically, and you must have a control system which will generate a loop in which your if temperature rises to a certain limit, then your cooling valve should be operated on its own, and so on. That represent the automation and control of the process, and that is one of the means through which we can control our hazards. Prevention of hazardous condition in process operating by utilizing automatic control, relief systems, interlocks, alarms. That means we have installed on our system so that they may get sensitive when we reach towards any threshold values, and any necessary events are either automatically initiated or alarms get ringing, and personals may get take necessary measures. Limitation of the loss when an incident or accident occurs. How can we limit the loss actually? And this loss is not only the person, property, and environment. In property, we have all those losses which I have seen in the previous slide, which represent the loss of the equipment, which represents the cost of repair, which represent the loss of production, which represent the loss of earnings actually. In addition, it may be an injury, it may be a loss of person, it may be a loss to environment in terms of damage to our ecosystem, which may be long lasting. So any question? So I'm open for the questions. This is chapter 2 of your plant design and economics for chemical engineers by Peter and Timmerhorst. उसका कुछ पोर्शन हमने इनिशिएट किया है, कुछ पेजेस हैं इनिशियल 5-6. नेक्स्ट हमारा जो टास्क होगा टुमारो इज हेजोग एंड फॉल्ट एनालिसिस. If you have any questions, you can raise.
Excuse me, sir.
जी.
सर स्लाइड्स कब शेयर करेंगे?
पिछली स्लाइड्स आपको शेयर कर दी गई हैं, आपको ईमेल आ गई है, इसको कल शेयर कर दूंगा.
ओके सर.
आप लोग अपनी ईमेल चेक कर लीजिए करिएगा. जैसे ही पढ़ाया करूँगा कुछ मेजर कंटेंट हो जाएगा स्लाइड का, तो आप प्रेजेंटेशन का, तो वो शेयर हो जाए करेगा. रेस्ट आपको रेफरेंसेस ऑफ एंड ऑन बताता रहता हूँ कि आप लोगों ने अगर उसको डिटेल में पढ़ना है तो दोज मटेरियल्स आर अवेलेबल. प्लांट डिज़ाइन इन इकोनॉमिक्स बाय फॉर केमिकल इंजीनियर्स बाय पीटर एंड टिमरहॉर्स्ट. उसका 5th एडिशन में फॉलो कर रहा हूँ. 5th एडिशन के अंदर चैप्टर 2 है, 4th एडिशन के अंदर चैप्टर 3 है ये, एंड चैप्टर नेम इज जनरल डिजाइन कंसिडरेशंस. Any other question before I finally sign off? Thank you class. Allah Hafiz.